Dude, welcome back. I'm glad to have you here because I want to talk about something on the Daily Dean. Very interesting. Astronomy. Okay? When you have when you think about astronomy, you may be thinking about stars and all the cool space junk out there. So in the universe, which is related to the expansion of the universe. When you talk about the expansion of the universe, we have this idea that things are just moving apart from each other, which is right, but the better analogy would be like I've heard people describe it as a balloon, which I've mentioned before, or bread dough, right? When yeast makes it, rise or however bakery baking works, right? You have 2 points on that bread loaf or on a balloon, and when you blow it up or when yeast causes it to expand, it moves those points apart in every single direction at once because that's how the expansion of the universe works. Basically, it stretches the space in between things that gives us the appearance from from the perspective of Earth that things are moving away from us just because they're expanding in every single direction at once. So, quick rundown there. But what governs that expansion? What factors play into it? Well, first off, is just the expansion rate itself, right? There's some certain rate. I can't tell you the number specifically. I didn't memorize that, but I can tell you that what fights against it is the matter of the universe. The matter of the universe wants things to come together because gravity, pulls mass together, right? So when you have gravity affecting everything across the universe at once, right? All the mass wants to come together. So you can say that the density of the universe, all the mass in all of the space everywhere, fights against the expansion rate of the universe. As in, when things have mass, they act on each other billions of light years away, causing this force that counteracts the expansion rate. Because the expansion rate of the universe, you can think in terms of like Newtonian physics, as in if you have a apple and you throw it at I think it's like 17 meters per second or maybe 400 meters per second into the air, it'll reach escape velocity, at which point it has enough kinetic energy to fight against the pull of gravity. And so it won't fall back down, it'll continue off infinitely into space. That's how you can think about the universe's expansion. When you have the universe, when you have a escape velocity for every galaxy everywhere, how does the mass of each galaxy fight against that escape velocity, right? Because because the expansion rate wants things to move apart. It stretches the space everywhere, but gravity fights against it because it wants things to come back together. Just like how the Earth pulls an apple back down, slowing it down until it reaches, the point at which there's no return at its escape velocity, terminal ending point, whatever you want to call it. And that's how you can describe it in terms of more generalizable ideas. But I know people are going to bring this up. Dark energy, yes, dark energy plays a fact in the expansion rate of the universe. If you aren't familiar with that, then you don't have to be familiar with that, with the point I'm trying to make. But if you are familiar with it and you're thinking, wow, why isn't he mentioning dark energy? It's because it's not relevant to the point I'm trying to make, which is the universe will continue expanding forever and ever. There's not enough mass when you weigh everything up, stars, galaxy, solar systems, etc. There's not enough mass and density in the universe to pull things back together against the expansion rate. The expansion rate will continuously pull things apart, farther and farther, stretching them away until eventually the light coming from other galaxies will just have too much space to travel through to reach some civilization in the future. So, I want you to consider you're an alien life form. I mean, technically alien to us, but just a regular life form to them. You look up to the sky, and as a human, you would expect to see stars or beautiful images of how, crazy space looks. But when you do, there's nothing. It's blackness. Pitch blackness. Because there's no light, no infrared radiation, no ultraviolet radiation, and etc. that reaches your civilization. When you look up, you don't see beautiful images of Starry Night, of the Hubble Space Telescope. all those things don't exist in your civilization because things are just too far apart to even reach you. You don't have the same opportunity as we humans do to look up and see wondrous things, to see beautiful images that people depict of the universe and other things like that, because you just were born in a wrong time and place. So think about, for a moment, how awesome that is to be able to live in a moment that is just a fraction of a second in terms of cosmological scale, to see cool images of red giants, brown dwarfs, white dwarfs, black holes, all this other stuff that a future civilization won't have the opportunity to see because the expansion rate of the universe goes on infinitely until there's just nothing left. We have some hope that there's some alien civilization like us because we haven't searched all of the universe. But when you're an alien civilization way in the distant future and you see nothing, even when your civilization builds its version of the Hubble Space Telescope and you point it up to the sky and there's nothing, it's kind of downing that you're the only civilization in this entire universe. So think how grateful we should be to have this opportunity to explore the universe, its mysteries, cool photos, whether or not we're alone, because a future civilization won't have that opportunity. Hope that's cool to think about. Thank you. Oh, side note, PBS space-time and non-Euclidean geometry. Look those two things up, more specifically, PBS space-time, dark energy series, and non-Euclidean geometry from Hyperbolica. Those two series / videos are freaking awesome if you want to learn more about the universe and stuff. So, thank you. I'll put them probably in the bottom description. Thank you.